Hi guys, welcome back. Today we are going to learn about vectors with fractions and ratios. We've got three success criteria, and the first one is to express vectors with midpoints. So for this question, ABC is a triangle and M is the midpoint of AB. So we want to express the vector C to M in terms of A and B. So if you are given a midpoint, then we need to write the fractional vectors on the diagram. So A to M is 1/2 of A to B. And M to B is also 1/2 of A to B. So write in capital letters first, and then we can convert these to lowercase. So to get from C to M, we need to go from C to A, and then from A to M. So C to A is minus A, because we're going against the arrow, and A to M is 1/2 of A to B. So we need to work out what A to B is. So to go from A to B, we can go from A to C and then from C to B. So that would be A plus B. Then we can expand the bracket. So 1/2 of A plus 1/2 of B, and then simplify. So minus A plus 1/2 of A would be minus 1/2 of A, and then plus 1/2 B. And that's our answer. Here's another question. So again, ABC is a triangle. E is a point on AB, and F is the midpoint of BC. C is also the midpoint of AD. And we want to find the vector F to D in terms of A and B. So B to F is 1/2 of B to C, and F to C is also 1/2 of B to C. Because C is the midpoint of AD, and A to C is 2A, C to D is also 2A. So if we want to go from F to D, we can go from F to C, and then from C to D. So F to C is 1/2 of BC, and C to D is 2A. So we need to work out what B to C is. So B to C is B to A, and then from A to C. So we've got minus 3B plus 2A. Again, expand the bracket, so times minus 3B plus 2A by 1/2, and then simplify. So we've got 3A minus 3 over 2B. Here's two questions for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So for the green question, we want to find the vector P to A in terms of A and B. So D to P is 1/2 of D to C, and P to C is also 1/2 of D to C. So if we want to go from P to A, we can go from P to C, then from C to B, and then from B to A. So P to C is 1/2 of D to C. C to B is minus 4B plus A, because you're going against the arrow. And B to A is minus 3A minus 2B, again, because we're going against the arrow. So we need to work out what D to C is. So to go from D to C, we can go from D to A, then from A to B, and then from B to C. So going all the way around the outside, that simplifies to 4a plus 5b. And then we need to expand the bracket by timesing 4a and 5b by half, and then simplify. So we just get minus 7 over 2b. For the AMBER question, we want to find the vector m to n in terms of a and b. So a to m is a half of a to b, and m to b is also a half of a to b. N to e is a half of a to e, and a to n is also a half of a to e. So if we want to go from m to n, we can go from m to a, and then from a to n. M to a is a half of b to a, and a to n is a half of a to e. So we need to work out what b to a is. Well, that would be minus a plus b, because you're going against the arrow. And a to e is going all the way around the outside. So that's going from a to b, from b to c, from c to d, and then from d to e. And that all simplifies to minus b. So if we expand both brackets and then simplify, we just get minus a half a. So now we've completed success criteria 1. So now we're going to move on to success criteria 2, which is to express vectors with ratios. So in this question, P is a point on YZ so that it's in the ratio of 1 to 3. We want to find X to P in terms of A and B. So when converting ratios to fractions, the denominator is the total of the ratio numbers. So that means that Y to P is 1/4, because it's 1 out of 4 of Y to Z. And P to Z is 3/4, because that's 3 parts of the ratio of Y to Z. So if we want to go from X to P, we can go from X to Y, and then from Y to P. X to Y is just B, and Y to P is 1/4 of Y to Z. So we need to work out what Y to Z is. So to go from Y to Z, we go from Y to X, and then from X to Z. So that's minus B plus A, or A minus B. Again, expand the bracket, so times A and minus B by 1/4, and then simplify. So X to P is 1/4 of A plus 3/4 of B. Here's another question. So P is the point on BC so that it's in the ratio 2 to 3. That means B to P is 2/5 of B to C, and P to C is 3/5 of B to C. So if we need to go from A to P, we can go from A to B, and then from B to P. So that's 2A plus 2/5 of B to C. We need to work out what B to C is. We go from B to C, we go from B to A, and then from A to C. That's minus 2A plus 3B. Again, expand the brackets, and then simplify. So we can turn 2A into 10/5 of A to make it easier to simplify. So A to P is 6/5 of A plus 6/5 of B. Here's 2 questions for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So for the green question, we want to go from B to P. So to go from B to P, we can go from B to C, and then from C to P. So to go from B to C, that's 2B minus 4A, and C to P is 2/3 of C to A. To go from C to A, go from C to D, and then from D to A. So that's minus 5B plus 2A. Expand the bracket, and then simplify. So B to P is minus 8/3 of A minus 4/3 of B. For this amber question, we need to find the vector P to C. So P to C is P to B plus B to C. P to B is 3/4 of O to B, and B to C is A minus 2B. So we need to work out what O to B is. So to go from O to B, we can go from O to A, and then from A to B. So we simplify and expand the bracket, and then simplify again. So P to C is 3/4A plus 1/4 of B. Here's a challenge question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So in this question, B to C and A to B are in the ratio 3 to 2, and we need to find the vector O to C. So B to C is 3/5 of A to C, and A to B is 2/5 of A to C. Now we need to go from O to C. So we can go from O to B, and then from B to C. O to B is 4A plus 3B, and B to C is 3/5 of A to C. So we need to work out what A to C is. Well, if we can't find a full vector, we need to try and find one of the fractions of the vector. We know that A to O and then O to B, that would give us A to B. So 2/5 of A to C is minus B minus 2A, because we've gone against the arrow to go from A to O, plus 4A plus 3B. So that's 2A plus 2B. So if we want 3/5 rather than 2/5 of A to C, we can divide it by 2 and then times by 3. So 3/5 of A to C is 3A plus 3B. And then we can simplify. So O to C is 7A plus 6B. Now we've completed success criteria 2, so we're going to move on to success criteria 3, which is to answer vector proof questions. So to show that two vectors are parallel, you need to show that they are multiples of each other. So for example, A plus B is parallel to 3A plus 3B because 3A plus 3B is 3 lots of A plus B. So you can see by drawing the vectors that they are parallel to each other. To show that two vectors make up a straight line, we need to show that they are parallel and they have a common point. Like so. So in this question, we want to prove that x to y is parallel to O to R. So if M is the midpoint of PQ, then that means that M to Q must be vector A. And if N is the midpoint of O to R, then N to R must be 3A. N to X will be a half of N to M. And X to M will also be a half of N to M. R to Y would be a half of R to Q. And Y to Q is also a half of R to Q. Now we can see from the diagram that O to R is 6A. So we need to work out what X to Y is. So to go from X to Y, we can go from X to M, and then from M to Q, and then from Q to Y. X to M is a half of N to M. M to Q is A, and Q to Y is a half of Q to R. So N to M will be minus 3A plus 2B plus A. And Q to R is minus 2A minus 2B plus 6A. So we can expand the brackets and then simplify. So X to Y is 2A. So we can see that O to R is 3 times as big as X to Y. So as they are multiples of each other, then they must be parallel to each other. Here's another question. So this time we want to prove that FGE is a straight line. So first of all, we need to work out F to G and then work out G to E. So F to G is F to A and then from A to G. We've got a half of B to A and 3/4 of A to D. And both brackets and then simplify. So F to G is minus a half A plus 1/4 B. Then we need to work out G to E, which is G to D plus D to E. So G to E is minus 3/2A plus 3/4 of B. Again, we can see that G to E is 3 times as big as F to G. So as they are multiples of each other, and they share a common point, which is the point G, they must make a straight line. Here are 4 questions for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So here's the green question. We want to prove A to D is parallel to P to B. So C to P is 1/4 of C to D, and P to D is 3/4 of C to D. So we can say D to A is 2A plus 3B. So we need to work out P to B. P to B is P to D plus D to A plus A to B. So P to D is 3/4 of C to D. So we need to work out what C to D is. C to D is 12A plus 8B. We expand the bracket and then simplify. So P to B is 6A plus 9B. Now we can see that P to B is 3 times as big as D to A. So as they are multiples of each other, they are parallel to each other. Here's the amber question. So we want to prove MNO is a straight line. So we need to work out the vector M to N and then the vector N to O. So M to N is M to B plus B to C plus C to N. We need to work out A to B, which is 3A plus 3B, and C to D is 6B minus 2A. Again, expand the brackets and then simplify. So M to N is 2A plus 2B. Now we need to work out N to O. So N to O is N to D plus D to O. Well, N to D is 3/4 of C to D. So we need to work out what C to D is. C to D is 6B minus 2A. So we expand the bracket and then simplify. So N to O is 5 over 2A plus 5 over 2B. So M to N is 4/5 of N to O. So as they are multiples of each other and they share a common point, which is the point N, they must make a straight line. Here's the red question. We want to prove MND is a straight line. We need to work out M to N and then N to D. M to N is M to B plus B to N. So that's a half of A to B plus 2/3 of B to C. We expand both brackets and then simplify. So M to N is B minus 2A. So now we can work out N to D. N to D is N to C plus C to D. So N to C is 1/3 of B to C, and C to D is 2 lots of A to C. So we need to work out what B to C is. B to C is 3B minus 6A, and A to C is B minus 2A. So we can expand the brackets and then simplify. So N to D is 3B minus 6A. So we can see that N to D is 3 times as big as M to N. So as they are multiples of each other and they share a common point, which again is the point N, they must make a straight line. And the final question, the purple question, we want to prove P to Q to R is a straight line. We need to work out the vector P to Q. P to Q is P to A plus a to q. B to a is 1/4 of b to a, and a to q is 2/3 of a to c. B to a is minus 2a minus 3b, and a to c is a plus b. So we can expand both brackets and then simplify. So p to q is 2/12 of a minus 1/12 of b. Q to r is q to a plus a to r. Q to a is 2/3 of c to a, and a to r is just 2a. So we need to work out what c to a is, and that's minus a minus b. So expand the brackets and then simplify. So q to r is 4/3 of a minus 2/3 of b. So we can see that q to r is 8 lots of p to q. So as they are multiples of each other and they share a common point, which is the point q, they must make a straight line. And now we've completed success criteria 3. So now we've completed the final objective. It's time to end the video. Hope you enjoyed it and hope you found it useful. See you next time.